we have and we're going to go over these rules a little bit more, but there's a property. So let's write this one down. This one looks kind of difficult. So let's write down a first example problem, x to the negative fourth times x to the ninth times x to the fourth. When you look at that one, what you would notice is that the base is all the same. They're all x. There's no different letter besides x. And when it's that way and you're multiplying, then the trick is that you add the exponents together. So you would say negative 4 plus 9 plus 4, and your final answer would be x to the ninth. The negative 4 and the positive 4 would turn into 0. But if you typed in your calculator, negative 4 plus 9 plus 4, it's going to tell you it's x to the ninth. So if you are multiplying your exponents, the trick is that you add them. Okay. We go down to this one. If there's something on, let's write this one down. So I'm going to write it kind of bigger. So if we've got 4x raised to the fourth power times 2x raised to the third power, then you need to know that that 4 on the outside of the parentheses is going to go with each one of these things. Because you don't have to write this part down. Just let me explain it and I'm going to erase it. Because what that means is you're saying 4x times 4x times 4x times 4x 4 times, right? That's what that means. So the shortcut is that we've got 1, 2, 3, 4 fours. So that part, since we have 4 fours, would be 4 to the fourth. And we've got 1, 2, 3, 4 x's, so that would be x to the fourth. So that 4 needs to go with each one of these things. And this is why, because that's what it means. Okay, that's kind of the trick there. So this 3 on the outside needs to go with each one of these terms. So that means that we would have times 2 to the third times x to the third. Well, you would actually want to figure out what 4 to the fourth is. I do not know that in my brain. So 4 raised to the fourth power is 256. So we have 256 x to the fourth times 2 to the third, that's 8, x to the third. So for our final answer, you would multiply the 256 times the 8, but then on your exponent, the x or the variable, since they're both just x's, you're going to add those exponents. So you're going to get 256 times 8, which is 2048. And then you're going to get, I'm sorry, my brain does that sometimes. So when we, I went ahead and put the answer. So we're going to add the 4 and the 3, not the 4 and the 7. So we've got an x to the fourth and an x to the third. So it would be 4 plus 3. And that's why my brain says 7, but that's what you would get. This would be my final answer on that one. Okay. So don't want to make you do all of these. Let's look at 6. So you'll notice that this negative 18n is on the inside of the parentheses, unlike it was before. We had something on the outside of the parentheses. So there's this negative 18n only, right? That exponent only goes with the a. It doesn't go with the 21. This one up here that we had earlier, this 4 was on the outside of the parentheses, which means it goes with both of these things. But since the negative 18n is on the inside of the parentheses, it just goes with the a. Okay, so this problem, we really can go ahead and remove the parentheses. This is just 21a raised to the negative 18n times 5a raised to the negative 8n. So you're going to multiply 21 times 5. You're going to do what you would always do with the numbers. But the variables, the a's, if you're multiplying, then you add the exponent. So you would say negative 18n plus a negative 8n. I'm gonna kind of write the answer. I know y'all are writing these down, but this is gonna be, so 21 times 5, you're gonna get 105, and then a negative 18n plus a negative 8n is gonna give you negative 26n. Negative 18 n's and a negative 8n would be negative 26n, and that would be the answer. So you're combining the ones that are alike. I'm going to skip to 8 because it's a lot more difficult than 7. So we don't have to work a ton of these, but this one right here, let's write it down. So 4, x to the 5th, z to the 5th, divided by negative 2, x squared, z. Okay. This is why, so if I have an x to the 3rd over an x squared, that means that I have x times, you don't have to write this down, I'm just trying to explain why we're doing what we're doing. But that means I've got x times x times x, and then x times x on the bottom, okay? And so when we're working a problem like that, we would say, well, this x will cancel out with this x, and this cancels out with this x, right? And we're just left with x to the 1st, that one's left. So the trick is that when you're dividing the exponents, you don't add them, you subtract if it has the same base. So 3 minus 2 would give you x to the 1st power, okay? So the first thing I do when I see a problem like this is I go, oh, there's just some numbers to deal with right there. So I immediately go, what is 4 divided by negative 2? Or I see if I can simplify that fraction. And 4 divided by negative 2 is just going to give you a negative 2. Okay, then I go to my exponents. So I have an x, my variables rather. I have an x and an x on the top and the bottom. One's to the 5th and the other's to the 2nd. I'm supposed to subtract those to reduce it. We've got a z to the 5th, and this z would be to the 1st. So we would say 5 minus 1. So negative 2, x to the 3rd, z to the 4th. That would be the answer. If any of the exponents turn out negative, you're going to have to move them to the bottom of the fraction. I'm sure we'll work one like that, but that's why it says use positive exponents only. Okay, I think you can handle number 9. We've worked one like that. Number 10 looks stressful. The only reason I say it looks stressful is it has a negative exponent, and that kind of throws people for a loop. So let's look at this one. Negative 9, a to the negative 6, b to the 5th, c raised to the negative 3rd. You need to remember that that negative 3 needs to go with every single thing here. Because it's on the outside of the parentheses. So right now, negative 9 is not being raised to a power, but whenever I distribute this, it's going to be raised to the negative 3. A is being raised to the negative 6 right now. So when I distribute that negative 3 to it, it's going to be negative 6 times negative 3. B right now is raised to the 5th, but when I distribute that negative 3, it's going to be 5 times negative 3. C is just to the 1st right now, so 1 times negative 3 is just going to be negative 3. Okay, so the next thing you need to do is it's okay to go ahead and type in your calculator. This, if you type in negative 9 and you do rooftop negative 3, hey, it's going to give you a really strange answer. It's going to give you a decimal answer. If you hit math, enter, it'll turn it back to a fraction for you. And the reason that it does is because this means, since it's raised to the negative 3, that we would write a fraction and we would put 9. I'm sorry, negative 9 to the third. And we've talked about this before already, that if it's a negative exponent, you're going to move it to the bottom. Okay. If on the top, I've got a to the negative 6 times negative 3, well, that's a to the 18th, because negative 6 times negative 3 is positive 18. I've got b to the, let's just work this as we go. We've got b to the 5 times negative 3, which is going to be b to the negative 15. If it's negative, you're going to move it to the bottom. And it's going to, when you move it to the bottom, it becomes positive. So since we got 5 times negative 3 is negative 15, we're going to say, we'll put it on the bottom. That gets rid of the negative. And C's already done. It's C to the negative 3, so it moves to the bottom. So the only thing I have left to do is figure out what negative 9 to the third is. And it is negative 729, B to the 15th, C to the third. I would probably stick that negative just out in front of this whole thing. I wouldn't put it on the bottom. So when I write my answer, I'd say, oh, negative 729, B to the 15th, C to the third, A to the 18th. Trying to give you a little bit of time to make sure you've got it. Let me scroll down here real quick. Okay. Trying to see how many more of these we're going to do. We're looking at one more. We're going to cover what to do with this. Actually, I'll probably do 2 more. So let's look at 12. Looks more complicated. So let me help you with 12. So I'm going to write this bigger just so that it's easier for you guys to see. So negative 2 to the 6th, U to the 5th, V to the negative 3rd, over 3 to the negative 4th, U to the negative 2nd, V to the 3rd, all raised to the 4th power. Okay. Here's what we've got. So this 4 has to get multiplied by every single thing, even if it is on the bottom. So that's going to look like negative 2. I'm looking at how they've got their answer. See that they didn't even, the number gets so big that they don't even put both of those things. So let's just see. So we've got negative 2 to the 6. And this is tricky because this 6 only goes with the 2 and it doesn't go with the negative. Okay, because the negative is not in parentheses here. So really what I'm going to do on this one is I'm going to separate those out. So I'm going to write this as negative 1. And I'm going to put that negative 1 in parentheses. That negative 1 is taking care of this negative right here. Then we've got 2 to the 6th. Okay, but this 4 on this outside still needs to go with both of these. Okay, hope that makes sense, because that's a little bit tricky because that negative only goes with the, it's just a negative 1. It doesn't go with it. It's not in parentheses, so it doesn't go with this raised to the 6th power. And the reason I'm putting it to the 4th is because the 4th has to go with everything. It has to go with the negative. It has to go with this. Okay, so U to the 5th times 4, V to the negative 3 times 4. On the bottom, We don't have a negative in front, so we can just say 3 to the negative 4 times 4, u to the negative 2 times 2, v to the 3 times 4. And I don't know why I said times 2, because we're multiplying everything times 4. So u to the negative 2 times 4. So we've just taken everything and multiplied it by that exponent of 4. So negative 1 to the 4th power just means negative 1 times negative 1 times negative 1 times negative 1. So it's just 1. So we lost our negative there. That's all that happened there. Negative 1 to the 4th is just 1. I can write down 1 to the 4th, but it's just 1, right? So we really can kind of just get rid of that. When you multiply something by 1, it's just done. Then we've got 2 to the 6 times 4, which is 24. We've got u to the 20th, 5 times 4 is 20, v to the negative 12, over 3. Negative 4 times 4 is negative 16. U to the negative 2 times 4 is negative 8. V to the 3 times 4 is 12. Okay, this is the part where we start sorting out where stuff goes. So if we go ahead and, so we've got 2 to the 24th is definitely staying on the top because that's a positive. If you type that in your calculator, it's going to be so huge that they don't want you to do that. They just want you to be like 2 to the 24th. 3 to the negative 16. Well, to get rid of the negative, right now this is on the bottom, so we need to move it to the top to get rid of the negative part. So it'd be 3 to the 16th. These, we've got u's on the top and the bottom. So u to the 20 minus negative 8. When you're dividing, you subtract the exponents. V to the negative 12 minus 12. So 2 to the 24th, 3 to the 16th. Now y'all know why I'm going over this. U to the 20 minus negative 8. Well, that's going to be a minus is a plus. So u to the 28 and then v to the negative 24. The only thing that's not good is you can't have any negative exponents. So we're good with the 20 u to the 28 being on the top, but the v to the negative 24th needs to move to the bottom and become a positive 24. So that would be your final answer. 2 to the 24th, 3 to the 16th, u to the 28 over v to the 24th. That is a lot. A lot. So I know, deep breath. Okay. On these last two problems, all it's asking you to do is factor them and see if something cancels out. You can use your quad program to factor this. If you typed in your quad program that A is 1, B would be 0, C would be negative 49, you would get plus or minus 7. And so when you go backwards, you could write it out. It's the difference of squares also, so you might know it that way. You could use the quad program for this as well. So you would get, if you use the quad program, you're going to get 2 7s. And so you're going to need to change them to minus 7, right, for your zeros. Y'all just took a test on this. Y'all remember doing that? Okay, so then you would go, okay, this factors out. And so your final answer was it's trying to get you to see what factors out, what you can cancel out. That's all you're having to do on those problems. When it says simplify by removing factors of 1, it just means factor it out, cancel out anything that can be canceled out. Okay. So that is help with support for 9.5.